Good day, everybody. It's noon in Poland, and we are about to start our first JRC4 seminar. And maybe JRC is something that we should start talking about first. So I'm here on behalf of UNIgreen, one of European universities, the Green European University that is encompassing 8 universities around Europe. And we have inside UNIgreen, we have partners from Portugal, which is Polytechnic University of Coimbra. We have partners from Spain, which is University of Almeria. We have partners from Italy, from Unimore. We have partners from Iceland, from Iceland Agricultural University. Partners from Bulgaria, from Plovdiv. Partners from France, from SubBiotech. And also from Belgium, from Liège. And it is a pleasure to speak on behalf of the Joint Research Center, which is focused on biodiversity, forestry, and agroecology, on today's topic, which will be focused on mistletoe in forest. We would like to show you some results of our experiments and on our research and answer the question, is mistletoe a threat indicator, or maybe is it an ecological partner we can work with? And of course, this problem is a little bit more than only forest, but because of my background, I'm working at the forest management department at Warsaw University of Life Sciences. I'll be talking mostly focusing on forest and research concerning forests. And most of our research come from Poland, but not only. So I hope that I can take you on a really nice journey here. This meeting is being recorded for the purpose of sharing it later with a wider audience to all the people that could not be with us today. So I hope there will be no problem with that. And the seminar is thought to last around 30 minutes, and then it will be followed up by a discussion. And because of some technical limitations, we will be using this question and answer button that is located probably on top of your Microsoft Teams window. It's there in my window, but the Q&A is a place that you can ask your questions with text, and we can later be sure that we answered all of your inquiries. Of course, maybe the time will not let us to answer all of them. Then we'll try to follow up with emails or other forms of communication. And I hope that you'll enjoy this seminar as I will. So let's start. And what we should start with. So maybe we should start with the main character of our seminar, which is mistletoe. In Latin, it is called Viscum album, and Viscum album is an evergreen semi-parasite that is able to perform photosynthesis. That is the reason why it's only a semi-parasite. So it needs water from the host, which is typically a tree, and then it can use the water and light to produce its own nutrients. And we have different species, or subspecies of Viscum album. There are 4 subspecies in Europe that we consider important. So Viscum album is the main name, and then we have subspecies. Subspecies Viscum album austriacum is the one that is growing on Scots pine and sometimes on Norway spruce. We have Viscum album, which is typically Irene. Yeah, I see. Can I unmute you? Okay. Am I being heard? Can you raise a hand or raise a thumb to mark that everything is fine? Is it working? Okay, great. Thank you. Sometimes we have some technical problems here. So we have those 4 subspecies. Viscum album is the second of them, and it's mostly attacking European fir, so Abies alba. And we have also Viscum album abietinum is attacking fir, and Viscum album is attacking deciduous trees, typically those of softwoods like willow or poplar. And of course, I was talking about 4 species, 4 subspecies. We have Viscum album subspecies Creticum, and this is an endemit growing only on the island of Crete in the Mediterranean Sea. But This is just the general knowledge. And of course, the popular knowledge is that Viscum album is a Christmas decoration. So typically people on this time of year start to think about it with the time of Christmas, time of joy. It should be white outside, but for many years it hadn't been. So we hope maybe this year will be nice. But there's one fairy tale about Viscum album, about mistletoe, that when you meet somebody under the Viscum album branch that is hung under door or under the ceiling in your house, you can steal a kiss, which is very, very common tradition here in Poland. Of course, it has to be an accident or it has to be not on purpose. So you are not allowed to carry it with you, for example. But what is important here that many people miss is that once you get the kiss, you should take the seed out of this branch. And when there's no seed left, then no kissing, sorry. But why I'm talking about the seeds? Of course, seeds are very important. Seeds are the ones that are making mistletoe spreading and growing. And seeds are known to be very liked by the birds, and they have one noticeable feature. When the temperature reaches a certain threshold, so typically it's minus something depending on the subspecies, -8, -15, -20 something, then the seeds are not able to grow. So what does it mean? When the winter is severe enough, the number of seeds that are able to germinate in the spring is low. But as we all notice, the number of winter days with really sub-zero temperatures, especially in this part of Europe, are extremely low. I mean, there's not enough of those days. That means that the viscum or the mistletoe is able to spread much more than in the past. And this is the first mechanism that we see that is promoting the growth of this species. How this species changes the forest ecosystems? So typically there's some bird or some way of migration, and we know that birds are the most common vector for mistletoe spread. So they are colonizing new places, or they are bringing seeds in the places that they know already. And when the tree starts to be parasite, then we see that there's I'll show you the details later, there's some correlation with the amount of the branches that are living and dead. When the branches are getting less and less needles or leaves, they leave a lot of light that can go down to the floor of the forest. And this means that the understory, the lower levels of the forest, can grow more rapidly. So at the end, when the tree is highly parasited, it can even occur that the tree will die. So eventually we have these changes that is going not only with the light availability, but also with soil nutrients. So the more light, more of the leaves, more of the needles, more of the fruits are going down, and they are being incorporated in the soil, in the humus, and then they can be used later on. Of course, this might be not a big problem for the ecosystem itself, but is of course a big problem for foresters. And is it really a problem, this mistletoe? We know that it has been with us for many, many years. I mean, decades, even centuries or millennia, but it was never a problem as it is now. So first mechanism I've told you about the freezing of the seeds, is only the first step. The second step that we see here that is occurring in our forest is that during the year of 2015, where we had a severe drought in our forest, the spread of mistletoe was even more advanced. So it is typically a species that is not thinking too much about water. I will explain this in next slides. But we know that mistletoe is getting a problem not only in Poland. So first, important articles come from Switzerland, but then from Professor Ligling that we are cooperating with. And then we see that this is spreading into different parts of Poland, of Central Europe, of even Turkey, and also Iberian Peninsula. So we wanted to know where the problem lays. So which parts of Europe, which parts are infected by the problem? And we started our research. We have gathered data and that we have already published in scientific reports about the number of mistletoe being recorded in different parts of Europe. And the black dots on the slide that you can see, especially in Central Europe and here on Iberian Peninsula, on the Balkans, Ukraine also, but also Turkey. These are the places that occurrence of mistletoe has been proven. And the colors in the slide, so the green is the color that shows the range of Pinus sylvestris. The orange one is the natural range of Pinus pinaster, and blue is a natural range of Pinus nigra. And we know that mistletoe, the subspecies of Viscum album, subspecies austriacum, is mostly connected with pine trees of different species, of course. So this was obvious for us that there will be a strong connection here, and we see it. Of course, Viscum is not growing everywhere when the host tree is apparent, and we were thinking what's the reason and what future we can have in front of us. And we ran an experiment with the climatic data, showing what is the potential range of Viscum album subspecies austriacum in current conditions, taking into account the climate, so the mostly temperature and precipitation limitations. And you see with the red color in the middle of the slide, we see that the highest potential for Viscum album is Central Europe and Iberian Peninsula. Not only, but mostly here. But we were also interested what would happen if the climate change will take more severe directions. So we used information from different scenarios of climate change, checking what will be the future of the range of mistletoe in Europe. And as you can see here, this is the least severe scenario, scenario B. This is SSP of 1.26. So it means that when the amount of energy that is coming to the Earth's surface will grow, we see that there's some small shift, especially here in Central Europe, of mistletoe going a little bit towards Baltic Sea and reaching south of Sweden. And this is the first information that we have, that the mistletoe will change, probably will change the direction of its growth. But not only this, we also checked the more severe scenarios. And for some reason, we see that in the most pessimistic for us scenario, so the highest growth of energy, of temperature, SSP 5.85, we see that the amount of Viscum in Iberian Peninsula is going to be lower. But is it a good information or bad? This is something we can discuss about. Typically, Central Europe stays under high influence, but we see that the Balkans and Turkey are also getting rid of mistletoe in this scenario. But this is coming with a price. Different research from our friends from Dendrology Institute in Poland show the different ranges of, for example, Scots pine, Pinus sylvestris in Europe under similar climate change scenarios. And as you see here with the green color, this is the current natural range of Scots pine. With the blue, this is the artificial range. And the red points here and there showing where Scots pine is going to be severely infected by current projections of climate change. But if we go with moderate, pessimistic, or different climate change scenarios, we see with red color that most of Central Europe will be heavily affected, and especially Scots pine will be heavily affected by the climate change. Therefore, we believe that even with the potential range of Viscum, of mistletoe in Central Europe staying the same, it will have, on one hand, less host trees to attack. So it means that the potential will stay big, but maybe there will be no places to grow. Or which would be less optimistic and much more pessimistic, it will just start killing our trees, especially here in Poland, and our forest management will have to change a lot, because maybe not all of you are familiar that 60% of Polish forests are dominated by Scots pine. So this is our most important species in terms of economy, in terms of ecology, in terms of social aspects of forest. Therefore, we have to think about what to do next and what are the next steps. Then, after knowing where the problem exists, we were thinking, is it a top or light problem? And what do we mean by this? We have run an experiment. We started with 300 sample plots located in central Poland. This is in our so-called Kozienice forest districts next to Vistula River. We have a big forest massive, big forest complex of about 40,000 hectares. And we scattered our sample plots along this complex to check what trees are being affected by mistletoe. Of course, this is a typical continental climate, a lot of rain in the summertime, especially in June, July, August. And of course, the highest temperatures also there. And it means that it is a typical case study, or the case study showing a typical conditions in which mistletoe is growing in our country. And what we have found, first of all, we see that mistletoe prefers older than younger tree stands. In the oldest ones, so above 120 years old, they were infesting more than 50% of the trees on sample plot, while the youngest ones were having less lower numbers. And we see two explanations of that. One explanation is that the trees in the younger age classes, so let's say up to age of 50, 60, maybe even 70 years, are still growing with the height. Maybe not, the growth is not that fast as it was in the first stages, but still it has this ability to escape from the mistletoe. So the crown is able to grow over mistletoe because it can grow taller. Whereas the older tree stands, they have two problems. One problem is that they don't grow on height. So if the mistletoe is attacking the top of the tree, it cannot escape. And secondly, they were here in the forest for longer periods, so they had much more possibilities of being infected. Therefore, the infestation rate is being higher. And not only the forest age is important here, but also we see soil fertility importance. So when the soil fertility is high and the trees they have a lot of vigor, they grow fast and they grow on height. You see here site index. This is the measure of 32 meters. They can grow up to 32 meters with this high soil fertility, and only 20 meters here, which means that the low soil fertility is not giving chance to tree to escape from the mistletoe problem. So we see here that this vigor is also playing a crucial role in this part. Then, of course, this is highly connected with the height of the trees, but not only the height in terms of meters, but also the relative height between the trees. These are measured with craft class, and craft class number 1 means that the tree is taller than nearest competitors. And here you see that 50% of trees that are the tallest in the surrounding are being heavily infested, which means that probably we can say that the birds as a vector of spreading mistletoe are sitting on the highest trees, which we can observe in the nature. So this makes sense from the ecological perspective. Whereas the trees that are not growing that fast or not growing that tall, and they are staying, let's say, under influence of surrounding trees, therefore they have less light. And this is the problem or the question we have in front of us. Is the mistletoe picking the places when there's more light, or the more the light, the more the mistletoe growth? We still don't know which was the first, but still there's some connection here. And then there's maybe the last but not least information about the trees. So we were checking the crown defoliation. The denser the crown, the less mistletoe there is. But still the question remains the same. Was it that the mistletoe is growing better when there's more defoliation, less needles, more light in the tree crown, or after its attack, there's less needles or less leaves or the crown getting sparser? We don't know the mechanism yet, but we see that there's some kind of connection, some kind of correlation there. And this was our research conducted on the sample plots using binoculars, but we were also trying to research how the mistletoe is influencing the tree growth. So we were using a dendrochronological method, sampling trees that were healthy, so they were having no sign of mistletoe in their crown, and we were using a typical dendrochronological method to see what's the growth pattern here. And we then compared this to the growth pattern of heavily infested trees. In this example, there were 6 or more mistletoes on one tree, and these trees were merged into this group that shows this negative, especially in recent year, negative trend in their growth. Of course, we were checking also different amounts of mistletoe infestation. So we were checking whether 1 mistletoe is making a difference, 2 mistletoe, 3, but just to show you the most contrasting results, I've prepared slides regarding this part. So when we put this data together, we get the green color showing the healthy trees and the red color showing the affected trees. And we used a methodology based on the way how to detect a budworm infestation in forest. We just changed the method to use it with mistletoe infestation. And maybe it's not easily visible here, but when you subtract from green red color, you get a result showing the difference in the growth rate of the trees. And as you can see here, the last 10 years, the growth is much, much smaller than it was in the past. And as you may remember from the beginning of my presentation, year 2015 was the year in which we noticed the highest drought, the biggest drought. So since then, in multiple parts of our country, we see the problem growing, and this is a beautiful example or terrible example of how it can look. Therefore, we see that the high number of infestation is making the biggest problem, which was maybe obvious for most of you, but we wanted to check it with empirical data. Not only we did check what was the impact of mistletoe, but in this Kozienice forest, we also wanted to check, is there a spatial correlation? Is there are the location of sample plots meaning something? And we found one connection between where the mistletoe is growing and how it grows. So typically, in a forest, you would suspect that the bottom or the sides of the forest will have a lot of light. So the mistletoe will be growing there a lot. But as we know, mistletoe is spreading mostly with birds, meaning some results, I don't have it here on my slides, but there were research being conducted on how mistletoe germinates. And typically, a seed of mistletoe is not able, during germination, to go through the skin of the fruit. So what does it mean? That it has to be somehow stratified or scarified, or it has to be digested, for example, by birds, and then it can germinate easily. So therefore, we know that the birds will be the highest vector of the migration, and we were thinking that maybe there's some kind of pattern here that, where there are birds, we will see more mistletoe. And typically mistletoe is connected with one particular species of birds, which is called missile thrush, hence the name. So everybody thinks that missile thrush is the highest or the biggest vector of mistletoe spread. That would be somehow positive, but the problem is that missile thrush is highly territorial. It doesn't migrate that much. So it stays typically in the middle of the forest, in the center of it, and it doesn't go on the outskirts, on the sides of the forest. So probably this theory is not sustainable. But if we look for other species that might be a problem here, so we talk about fieldfare and song thrush, which are of similar family as the mistle thrush, they are species that are typically living on the edge of the forest. So they are migrating between trees, between open land, then they go in, deeper in, then they go on the outskirts, they go out, and with this migration pattern, they are the highest spreaders of mistletoe seeds. But this is not the end of the story. More to this is that typically some of those species, and not only those, there are more species that are eating mistletoe fruits. They ripe in February. So February is the worst part for birds because there's nothing growing on the fields. So they are eating whatever there's in the forest. But we know that, as I told you in the beginning, that there's not enough winter. So the birds from the north, whereas there's a high winter still there, they are coming here for the winter time, but our birds are not migrating more south. That means that there's more and more and more birds living in this part of Europe during the winter time when mistletoe is ripening. So therefore, and you remember about the seeds that are not being frozen, so they can germinate easy. And then we have this story somehow connecting with each other. We also were thinking, on the other hand, do we really see the whole problem? What do I mean by that? So typically, our mistletoe research is conducted using binoculars. From the ground level, we look up, we notice the number of mistletoes, and we think that everything is done correctly. So in order to check this, we have cut down some trees and verified our results. So we have been observing from the ground level trees, and we have estimated the number of mistletoe on each of 200 trees to be 20 trees without mistletoe at all, up to 100 trees with high, severe 6 or more specimen infestation. And then we were also able to say that most of these specimens, if there are more than one on one tree, they can grow typically in the top of the crown or maybe in the middle, but typically not on the bottom. Okay, that's a typical way how you do a mistletoe research, because it's not easy to cut down trees only for that purpose, but we were able to convince some of our foresters to let us check what will happen when we cut them down. So after cutting, we were able to say that on one tree, there were 289 specimens of mistletoe growing. Of course, most of them were young, but still, this is the number we can go up to. Then we were able to say that sometimes observation from the ground level led us to make a mistake or error of not seeing a mistletoe of 50 centimeters in diameter. Why? Typically because it's hiding behind each other. And when you do a ground level observation, you are not able to see the tree from all the angles. You are somehow limited by its neighbors, by the understory, so it limits your field of view. Therefore, the errors were, for example, this is just one of the biggest. Don't worry, there were not many of them, but still they were happening. And we see that most of the mistletoe, especially the young ones, are growing in the middle part of the crown, which might connect somehow with the theory about birds sitting on the top of the tree, then eating the mistletoe, then pooping down, and with the digested fruits, they can germinate when they stick to the bark of the tree. But moreover, what is important here, I didn't say you during the first slides, that we have conducted a research and we've put one big mistletoe like this 50-centimeter diameter into a bucket of water overnight, and it transpired all the bucket, meaning that mistletoe is heavily dependent on water, and also it's let's call it water. It doesn't consider water as a problem. Therefore, during the drought, when the tree, especially for deciduous trees, they close their stomata, they close the assimilation apparatus, they do not take in oxygen, the CO2, they don't release oxygen, they don't photosynthesize. But mistletoe is not doing that. So it still uses the water, lowering the tree water potential. Therefore, it might kill the tree with high number, as we see here on the slide. And we also ran an analysis checking maybe we need some different perspective on seeing the mistletoe. Maybe we should look from the other side, from the top side. So we use drones, we use some aerial footage, we use laser scanning, we use orthophoto maps, and we run an experiment checking every tree crown from the top and combining this data with images of mistletoe, as you can see, for example, here and here. We see that there's a potential in this method, but it needs a little bit more action here, and we need to deepen our knowledge, especially because, as I told you, it is the highest problem in Scots pine, in Pinus sylvestris, and we know that the needles of Pinus are changing a little bit the color during the vegetation period. The same with the mistletoe leaves. Therefore, it's not easy to teach computer how to detect them automatically. We need more time on this probably. Okay, our time is going to an end, so maybe I'm gonna summarize this seminar somehow. I have some take-home messages for you. So first of all, we know that mistletoe is spreading, and we know that it's going to spread to the north due to climate change. And probably there's nothing we can do about it. We know that mistletoe likes trees that provide more light, or it's a light-dependent species and heavily light-dependent. We know that there's much more mistletoe on a tree that you can typically see. It doesn't mean that we don't see the mistletoe. Maybe we don't see the whole problem, but for sure we see the biggest specimen, which is already an important indicator of the infestation. And we know that when there is too much mistletoe, it will reduce the tree growth. The amount of this reduction is variable, but we see that there will be some consequences for the forest management. And we know that we can use remote sensing for the detection, but still more work we need for this, because we have two options. We can use very highly precision data, which is typically hard to gather and expensive, or maybe we can spend much time in providing better data for our learning and teaching methods for the computer to see the mistletoe, or maybe cheaper data that we can acquire with satellites, and then maybe we'll have the problem solved in this way. And it was a very nice time spending with you and explaining all the details that we have been researching on mistletoe. This work was partially supported by our National Science Center in Poland, and I was also able to do some part of the research during my fellowship in the Laboratory of Tree Ring Research in the University of Arizona. And it is a big pleasure for me to show you all the details that I have here. And I hope that there will be some questions that you can ask us, particularly me, on the Q&A session right now. So if there's any question, please do not hesitate. I think that also we can use raised hands and the option to unmute you, but I'm not that technically sure how to do it. So maybe we can try first with the question and answers. And I'm opening this bar. I see, yeah, Patrick Gonzalez asking question. Could it be the old trees are more infected due to reduced defenses immunity with age? And are there some trials going on to simulate this? I really like this question because this is something we were considering here. Is it that maybe partially old trees, which are not so, they are not responding well to changes in environment. So for example, what we see typically in this part of Europe, that the water level in the soil is dropping down. Some places it is slow, some places it is bigger or faster process, but still there is. It's happening, and maybe this is already influencing the tree's vigor or the tree's defense mechanism. But I would say that I can only speak about, let's say, the general overview or the general conditions. I don't know of any research going on about, let's say, functional or low level, let's say, tissue or cell responses here. I mean, that would be really interesting to know how it works and what are the details here. Because, for example, some of the newest research about this semi-parasite is showing that typically we believe that mistletoe takes only water and no nutrients from the host tree. But some research show that maybe it's not fully true. There are some cases or some examples showing that sometimes there's the exchange of nutrients going on. So with this new piece of evidence, maybe we should look more into this topic. Yeah, but that's all I can tell for now. Okay, I don't see any more questions. Is there anybody? Let me check if I see everything. Okay, I see this. Okay, I don't see any more questions. Okay, guys, so maybe while you are writing one or two more questions, I have some announcement at the end of this meeting. So because it is our first JRC4 UNIgreen seminar, I would like to say a little bit more about the second one that is upcoming. So we already have a presenter, and I hope that I found the best picture in the internet, but I'm proud to say that Manuela Abelo from Polytechnical University of Coimbra in Portugal will be the presenter of the next seminar on 16 December. It is also Tuesday at the same time, 12 o'clock noon, also on Teams, that we will notify everybody about it. And it will be focused on a litter decomposition at the riparian stream meta ecosystem. I've already seen a part of this research on another presentation of Manuela. I'm eager and waiting for the next seminar that is coming up, and I hope that this will be also interesting for everybody else. And I already invite you cordially to this seminar in next month. And as I see no other questions, and I see no raised hands, and I see no questions at all, so I think it's a good time to conclude this seminar. So again, it was a pleasure to be with you here today. Rabia, okay, I see raised hand. I'm not sure. Okay, I think you can unmute yourself maybe.
Hi, can you hear me?
Yes, I can hear you.
Okay. First of all, thank you so much for this informative session. It was really informative, and I got to know about a lot of things because my PhD research is on the Scott spine, basically. So my question is regarding that, like, how does the seed penetrates the Scott spine's bark?
Okay, so yeah, that's a good question. So the
Uh, I have
seed.
I have another question too.
Okay.
And the second one is, does the mistletoe rely on host immediately?
Okay, so I
Yes.
can answer the first question about the bark.
Yeah.
So
Yes.
typically, when the seed is being digested, we believe by the birds, it falls down somehow here on there, and it has this gluey substance over the seed itself. So it sticks to the tree, typically to the bark. And of course, depending on the place when it grows, but if it's a bark of Scots pine in the branch part, in the crown, the bark is typically very thin, right? It's not that heavy or that thick as on the bottom of the tree trunk. So then with this bark being so thin, the tree has not, the mistletoe do not have that big problem into penetrating this, because the seeds germinates as normal. Then when it goes through phloem, which is typically soft, it stays on the cambium level. It don't grow into the wood immediately. It stays there, and then the wood overgrows the mistletoe. Let's call it. I'm not sure about the English name, but I think it is called sucker or the root. So the root is being overgrown with the tree, with the wood of the tree that is hosting on. But I'm not sure I can answer the second question, because the seeds of mistletoe are quite small, so they do not have a lot of nutrients in it. So it has to somehow fast and easily adapt to the new environment. So I would say that it has to start fast, but this is up to check. I'm not an expert in this field. Thank you for this question. Manuela, I see your raised hand. I think you can unmute now. Manuela, can you hear us? Can you unmute yourself? I don't hear you. I'm not sure.
Okay, it took me a while. It's just because
now it's working.
I wrote some questions and you did not see them.
Okay, I'm going to question and answers. Oh, well, now I see. Okay.
Yes, I wrote it twice, in fact.
Okay, there are two sides. Mistletoe is disappearing in some areas while it increases in other. And since it's considered a keystone species, the disappearance for some areas might treat biodiversity. Yeah, that's a good question. So for now, we know that there's a high or huge spread of mistletoe, especially in Central Europe. We do not see mistletoe to be declining anywhere yet. But our research showed that the future climate change, with any of the scenarios, will likely end up with some changes, some shifts in the range of mistletoe, which we are not sure on the full scope. We see the potential, climatic potential of mistletoe growth, so we know how it's going to behave with the climate change. But then that's just one side of the story. The other side is the host availability. So when there's no pine trees, there will be no mistletoe. Of course, not Album subspecies austriacum. Of course, there are other mistletoes that might benefit, but I didn't have time to show you the whole picture. In the paper I showed there's more research about it. Typically, what we see is that the mistletoe will be, on one hand, as I told you, is limited by frost. So the north limit, then south limit is limited by temperature. Typically, when there's too hot and there's not enough water in the environment, the mistletoe doesn't have water to take it from, because the trees are already dying and suffering. So that's why the Pinus sylvestris range is going to change so much. We will see big differences in the climatic conditions, especially in Central Europe.
Okay, but I would like you to comment also on, because in fact, well, here at Portugal, we don't really have mistletoe, or very little, due to the conditions you just described. But in some other places, it's related to deciduous trees. You only spoke about pinus trees. So do you know if the pattern also applies to deciduous trees or just to pine?
Yeah, so for example, we run an experiment about Abies alba, so it's English is European fir, right? In southern Poland. So of course, there are different ranges of different species of deciduous trees. And we see that there's some connection between some of the subspecies of mistletoe and some of the host trees, as I told in the beginning. So we see that, for example, with for Scots pine ecology, typically it has short crowns. So the short crowns and the mistletoe is not growing on the tree trunk, or very seldom. Therefore, it has a limited range on a tree that it can grow on. And for example, for Abies alba, the tree crown is typically long, very long, up to the bottom of the tree. And we ran the experiment in Polish mountains that some of the tree crowns were heavily infested. Up to 70 or 80% of the volume of the tree crown was the mistletoe. So not only it sucks water out, but also, if you can imagine, mistletoe, it's much heavier than the branches with needles. So it's also a mechanical stress added to the tree. So generally speaking, we did not research on every deciduous trees, but we know that that deciduous trees will not be beneficial from climate change. Typically, species like oak, beech are concerned to be the winners of the climate change race. So this is one problem. Then we have those temperature and precipitation and freezing limits for the mistletoe. But for example, mistletoe is not growing, Viscum album is not growing on hardwood trees like oaks. So, but Viscum album, Latin name album means white, and typically when you talk with biologists, this mistletoe is called white mistletoe in English. And in contrast to yellow mistletoe, which I do not remember the Latin, but I think it's Loranthus or something similar, this one grows on deciduous trees, especially on the hardwoods. So it's not, it means that no tree can be safe, but there are different parasites waiting for the spread and will come along with the new species. And about your question of biodiversity, yeah, this is a good one, because I had this discussion when I visited University of Lisbon, and they asked me this question, but why are you so worried? There will be more light, more species, the forest will look better. But from forestry perspective, when we have, wood production is one of the important pillars of the economy. We have to take care of everything. So from this perspective, this is not good. From the perspective of biodiversity, we don't know what's going to happen next. This is a dynamic problem. So when let's say we have a forest that is only Scots pine, the question will be, what will be next? If the climatic and soil conditions are not allowing any other trees to grow there, which is sometimes typical here in Central Europe, then what's going to grow there if there's no Scots pine? We don't know. Of course, nature will find a way, but this is a long process. And we know that, on the other hand, we have to act fast, for example, with carbon storage and capture. So for sure, it's not an easy answer, and I'm not feeling the best prepared person here to answer it. But I would say that this would be a great thing to discuss more on maybe next seminars with some biologist and somebody more aware of these topics. So it was a big pleasure to have you here. As I told you, this meeting is being recorded, so the recording will be available later on the UNIgreen website, and I will promote it, of course. And I hope to see you on the second seminar that will be run by Manuela next month in 4 weeks' time. So see you then. It was a pleasure. Have a good day, and bye-bye.